Good morning, good afternoon, wherever you are in the world. Welcome to Codebase Alpha. This is episode 34. It's a Wednesday in the afternoon here in the UK, and we're going to build a synthesizer. We're going to do a new project. So one of the hardest things about streaming is coming up with new projects each time, and this one really came about a bit by accident in that Cody Beard, welcome to the stream. Good afternoon to you. Yeah, this kind of project idea arose from working on the AlphaBot, in that I wanted to get some kind of sound effects. I wanted the hey command to work in there, and working in .NET Core, there's not a lot of choice in actually how you get that to use audio. And in the end I used a package called NAudio, which is designed by a guy called Mark Heath. Oh, what's happened there, Coded Beard? Never mind, you got timed out by by Nightbot. Sorry for that. So yeah, this package NAudio by Mark Heath, I installed that into the AlphaBot, and simply used one of the classes in there, which is an audio file reader, to play a WAV file which is held in resources, and didn't think much of it after that. And I started to look at what that package could do, that library could do. And it's got an awful lot in it, and it's really quite interesting when you start getting under the covers and seeing what it can do. So I was thinking, well, what can I do on stream using NAudio? And then I came across another member of the live coding team. His handle is JavidX9. I'll give him a shout out. You may have come across him. He's got some really, really interesting streams, and they're all in C++. Javid X9, and he actually built a synthesizer, a sound synthesizer in C++, and he wrote it right from scratch. So even the low-level sound card interactions were written. They weren't written on the stream, but he wrote all that himself. I thought, well, maybe we could do the same kind of idea using NAudio, and actually try and take it a bit further than he went, with some kind of graphics, like I don't know, we can have some level indicators, and we can have a nice GUI, and we can have a spectrum analyzer and things like that. So that's kind of what I'm thinking. Linkstumps, welcome to the stream, good to see you. So that's what we're going to try and do, and we're going to build it in WPF using .NET Core 3. Now, full disclosure, I've never used .NET Core 3, so that's going to be a first. And even bigger thing, I've never ever written even one byte of WPF code. I've never written any XAML. So it's going to be a bit of an adventure for all of us. So if you are a seasoned WPF XAML kind of programmer, you have to forgive me. I'm learning this as I go along. So we'll just take it as it comes. We're going to keep it really simple to begin with, and then kind of try and build it up over the course of several streams to see how far we can get with it, really. And when we actually get to implementing some sounds coming out, then we're might have to fiddle around with the audio on the stream so that you can hear it, because I'm not sure what the sound levels are going to be like. So you're a seasoned judgmental programmer, Linkstump, say. Okay, well, don't judge me too harshly, because I've never written one byte of this before. So the WPF component really isn't a big part of it, but we're going to start off with that. So let's jump into the code. And what I did yesterday, just in preparation, is I created a .NET Core 3 WPF project and pushed just the empty project up into GitHub, and that's what we've got here. So we've got a main window, a XAML file for that. We've got a XAML.cs, and there's an app.xaml, which I don't think we need to touch at all. So this is the XAML.cs file, the code behind the XAML, and you can see it's just basically empty. And over here on the main window, we've got nothing at all really. We've got a window with an empty grid in it. So let's have a look at what we can do. So I've got extensive notes. So if you see me referring to notes, it's because I do need the notes in this case to figure out exactly what we're going to do. And the main point of the stream is not to build a WPF app, which looks really nice. It's to build the synthesizer and explore the NAudio digital audio library. So let's make a start, and let's try and get at least some controls onto this form. So I don't think we need a form, not to start with, any quite as big as that. So let's just change the size of it. So 350 by 550. That should be okay. And that might actually fit in the screen on the left-hand side there. It does. Okay. And we want to do a grid. So let's we use some CodeRush to create the grid. So row definitions, yeah, so what's the height we want? I think we can leave the grid height and width. I think that should be okay just to get rid of those. I don't really suppose we really need a name for it either. We're not going to refer it in code. So our row definitions, I believe we have row definition, and it's going to be a height, isn't it? And we're just going to set those to auto to begin with, just see what they look like. And we're going to have we're going to start off with 4 rows. No, well, maybe 5 rows. That should be okay for that. And then we need something similar for the column definitions. We're going to have 4 columns. Let's put the column definitions in. Column definitions, and this will be column definition. As I say, this is really the first XAML I've ever written, so we'll just take it slow. Shout out if you've got any ideas, but I just think that it should be fairly easy to kind of to sort this out. We want a very, very basic UI. So Cody Bird is saying that the XAML, the app.xaml is like the program.cs. Okay. End up wanting to use DI. That's where you put it. So we're not going to use any DI in this project. It's all going to be, kept at a fairly simple level. Yeah, the preview window, Cody Bird. That's this. We're not using a preview version of Visual Studio 2019 here. What I've done, this is production 2019. I've gone off into tools, options, and under preview features, I've just ticked this box to say use the preview.NET Core SDK, and obviously I've installed the preview 5 bits from the website. So we're not using a preview version of Visual Studio, so we should be okay. So this is going to be width, not height. So let's fix that. Okay, and our preview is working again now. Okay, so that's that. So what we're going to put in is basically we're going to have a volume. We're going to have a volume control. We're going to have an on and off button on the UI to begin with. So nothing spectacular, and we're going to build the UI up with extra features, extra controls to control our synthesizer as we start to develop features. But the kind of goal of the first stream really is to just try and get a monophonic synthesizer which we can play with our computer keyboard. Hopefully we'll have enough time to do that. Okay, so the next thing we're going to need to have a volume label. So let's create a label. There we go. And this is going to be in grid.row. Which row should we put it in? Row 1. Okay, so we've got some padding at the top there. And it's going to we're going to align it to the right because it's going to be up against our volume slider, and it's going to have content, and that's going to be volume, and this is coming up right in the corner here, so we're probably going to want to put some margin around that, aren't we? So let's just make some space here. So margin, I don't know what's the margin could be. Let's have Let's try 5, 5, 5 and 5. What does that look like? So okay, well that seems alright. Maybe we want something in row 0. Do we want something in row 0? Just to push this down. So row, yes, because we're auto-defining the row heights, aren't we? Okay, we'll just leave that for the moment. So that's our label. And then we're going to want a slider. This is going to be our volume control. This is going to be in grid row 1 as well. And it's going to be in grid column 1, and it's going to I'll give it a margin as well. Let's just use the same margin we used before, margin of 5 around it, and it's going to so normally I think we'd probably want to orient these kind of controls on an audio app. It would be oriented vertically, but we're going to do this horizontally, I think, because so we can just slide across. We may turn it round at some point and have it more like an audio control, like a fader, but we won't start off like that. And we need to give it a minimum, and that's going to be where's the minimum? So we're going to go from 0 to 1 on our slider. We're not going to work in decibels because that's kind of like -infinity to 0 decibels. We're going to work, like in percentage volume. So 0 will be silent and 100 will be the maximum volume, the volume of the audio that we're going to create, and then we'll be able to have it in between there. We won't want it at volume 1. Upgrading Dave, morning, afternoon, evening. Welcome to you. Good to see you. So there's that, and we're going to have to bind that to something, aren't we? So we'll the content, the value rather, is going to be a bound value. So now I believe we set it up with a binding, and then we set it up to a property we're going to create on our model. So like that. And then we're going to make this slider span across more than one column, I think. So grid column span, and we'll set that to 2, so it's across 2 columns. Okay, so what we got here. So then we want to close off our. So here's our slider here. Okay, so it looks a bit weird. So we'll see what happens there. So I think we need to change the width, don't we? So our column width is currently auto. So the initial one, let's make, I don't know, 55, and this one, I don't know, 400. And there we've got our slider. We'll slide across those 2 columns. Okay, it's looking a bit kind of high up, so we might want to put something like a dummy thing above that. Let's take the row definition. Let's make, so this is height is 350, so let's make this a height of 50. That pushes it down a bit, and then we can maybe put something in the top there at a future time. What else can we do? Oh, we call main window, we call this synthesizer. That should be our name of our window, and we've got our volume slider in place. Now we want, what do we want next? We want to have, okay, so then we need to have a reading, so we need to have the percentage volume appear over here. So this 400 is probably a bit too wide, so let's make that not 480, 380. So we've got a bit more room here, and we want a volume percentage to appear here. So we've got another label. So we're going to label, and this is going to live in grid row 1 again. Grid.row 1, and it's going to be grid.column 3, and it's going to be so it's margin. Let's do 5, all 5s again, just to see what that looks like, and then it's going to we're going to right align it again. So horizontal alignment is going to be horizontal alignment going to be right aligned. We might want to left align it, we'll see. And then the content is another binding to a property we need to create. This is going to be binding to a volume label. Okay. So we should have a label which will appear here. So looks like the width of that isn't quite right. We don't need 5 columns. We need 4 columns actually, don't we? So there you are. So that's column 1, column 0, 1, 2, column 3. So it should be in there with our label. There we are. That's in there. Yeah, I believe that's it. So let's kind of leave it at that. And now we want to have some buttons underneath that. Okay. Okay, so we can, I think there's a thing called a stat panel which we can put buttons in. So I think SP will give me a stat panel. We don't care about the name, but that's fine. And let's just bring these so they're aligned for us. The stat panel is going to be in grid row 1. And it's going to be in grid column 0. What else do we want? We want to span all 4 columns, so grid dot column span is going to be 4. A margin which will make, I don't know what make the margin. We'll just do all our 5s again. I'm surely sure that's not going to look right, but we'll see. And then should we make it? We'll make it span the remaining rows. Let's see how that works. Grid row span 3. Okay, so the stat panel should be down here somewhere, and we want some buttons in there. So let's create a button. The button's going to be called on. The on button. So the on button there. We'll give it a margin of 5. Content is going to be the word on. And we're going to bind that to a command which we'll need to define. So the command is going to equal oops, I need to go there. So command, and that's going to be bound to binding, and we're going to call that on command. Okay, and we can probably just close that off like that. And we've got that's manipulation, that should say margin. Binding on command, there we go. So we've got a button which has appeared there, so that's in the wrong row, isn't it? It needs to be row 2 by the look of it. There we go. And it's not big enough, it's a tiny little button, but we'll address that in a second. Let's just copy that and have an off button. So we need a width for these buttons. So let's pop a width in there and make it, I don't know, 50. And we'll do the same one here. So there's an on and off button and a volume slider. And we should have a label there, just that we can't see it. Column 0. That's in. This should be in column 0, shouldn't it? Grid column 0. I think that's where it is anyway. Oh, there we are. We have a label here. It's very, very narrow. So label. We'd have a label width 20. Let's make it a bit wider. Where are we? 40. Yeah, that's better. Okay, so that's something of a UI. We'll obviously have to come back to that at some point and tidy it up and also add some more controls to it. But we've got the basics. We've got an on and off button and we've got a volume slider. Okay, so there's some bits and pieces we need to actually to build now. So we need a view model. So let's add a view model. Add a class. We'll call it main window view model. Add that. Okay. And we're going to so this is what's going to respond to changes in the UI. So we need to inherit from I change notify, I notify property changed, if I remember correctly. I notify property changed. We need to bring that in like that, and we need to implement that. Okay, so we got our property change event handler, and now we need some properties on here. So we had a volume, so that was going to be we need a floating point number for our volume because it's going to be the actual amplitude of the wave that we create. So that's going to be, we're going to have an amplitude of our wave from 0 to 1, 1 being maximum volume, maximum amplitude, 0 being silent, of course, no wave at all. So property float, and the property is going to be volume. That should be okay for now, I think. We'll leave it like that. And then we've got that's the main property, isn't it, that we have to work with, the volume property. Let's spell volume correctly, shall we? Right, we also need a volume label, don't we? So we had that defined on our form, and we can say that's going to be, I want it to say kind of a percentage. So let's make that an interpolated string, and we'll say that's going to be the volume multiplied by, oops, now we need to have our curly brackets in here. We need to spell volume correctly. Times 100.0. But we want that to be an integer rather than a float at the end of the day. So let's wrap that in brackets and make that an int. Okay, so that's our volume label. So okay, let's wire up our commands as well at this point. We need to have a command class, don't we? So let's create another. You're enjoying me struggling through the WPF for the first time. Let's have a class called user command, and that's public class, and that's going to inherit from my command. So let's use that, and let's implement that interface. Okay, so it's got can execute and execute. So what we're going to need to do is we're going to need to pass into our command what action we want, and we'll define the actions that can happen as methods on our view model. So let's create a property here. It's going to be a private read-only. It can be an action, and we'll call that execute. That's what we're going to execute. So we're going to pass into here an action, which we're going to execute. And the same in here. And this one is simply going to run execute. Actually, let's just change this. I'm not sure. We'll just accept objects into there, and we'll worry about that bit in a bit. Let's see if that works. So let's just execute our command there, and can execute. We're just going to return true. So we can always execute these commands. Let's overload execute as I originally intended to do. I'm not sure which is the best way of doing it. This is an action. No, let's not do that. Let's create we need to create a constructor. Public user command, and we're going to pass an action into that. Call that execute, and we're going to say that execute equals execute. That should be okay for that. And then over here, in our model, our view model, we should then be able to define those commands. And we should be able to say public iCommand. You're just as bad with WPF. Yeah, I've said use it infrequently coded B. This is really my first time, so I'm trying to remember stuff and also look at the notes now. Seem really cryptic. I scroll down, so I'm just trying to figure out exactly what. So we had, what commands did we say we had in our XAML? We said we had two commands, an on command, and we wanted an off command, didn't we? There we go, an on and an off button. I'm not sure they're right way round. Yeah, they'll be okay that way round. So back in our model, we want an on command, and need to bring that namespace in, and a public iCommand off command. So we've got those. Okay. Right. Okay. We can make these properties like that, I think. Maybe that's the best thing to do. Okay. And we're going to want a constructor, aren't we? So let's try some constructor. Public main window view model. And here we're going to set up our on command, which is going to be a new user command. And we're going to pass in our action, which is going to be on, and we want an off command. And that's going to pass an action of off, and we need to define on and off. So private void on, it's going to do something, and private void off is also going to do something, which we'll figure out what that's going to do in a moment. So let's see if this actually runs. There we go. So we need a property, a non-property change to work with this slider so that our label can change. But we've got on and off buttons. I guess if I put a breakpoint in there on a on, we're not firing it at the moment. Okay. Well, we haven't instantiated a view model. That's why we're not wired up yet. So let's just close that down. So over in our main window, we need to do something here. So I think what we need to do is have we need some properties. So we need a private read only. This is going to be a main window view model. View model. And over here, what we can say is, what's that complaining about? Oh, we're in the wrong place, that's why. We need to be inside the class. Down here we can say that view model is going to be a new main window view model. And we need to say that our data context is equal to view model. And that's pretty much all we can do at the moment. I think let's give that another run to see what happens. So we've got a breakpoint in these two locations, so we'll see if those actually get wired up. Yep, they do. So we hit the breakpoint there, continue, and hit off, and we hit breakpoint here. So those look like they're wired up. Our main window, where are we? Here. I'm going to continue. Start off. We've got a 0 there. Okay, probably want a percentage sign after it, don't we? And then we need to make sure it changes. So this is going to be percent volume. So Kelly Beard says, I'm terrible at anything UI in general, don't have any eye for it. I'm exactly the same. So I'm a back-end developer. So you're watching me kind of struggle through designing a UI. It's going to be a rubbish UI. We'll try and tidy it up, and I'll try and learn something about designing with XAML. But at the moment, we're just trying to get something wired up so we can get to the meat of the actual project, which is actually to build some... we're kind of 40 minutes in, and we haven't built any digital audio components yet. So I would like to get into doing that if we can. So we've got those components done. So what else do I need to do? We need to have the volume label that changes, don't we? So what I'll be interested in knowing is our volume value actually changing? So what I think we're going to do is going to wrap this up. So we're going to cut that out, and we're going to create our own private method, I think. So I've got a note here about it being a protected virtual void, than what we need. So protected virtual void, and we're going to call it onPropertyChanged. And I think this is fairly standard practice in WPF, but do correct me if I'm completely wrong on that. And we're going to pass it in the name of the property we want to affect. Property changed. And in there we're going to pop that bit of code, and it's going to be name of the name of it's actually going to be property changed. There. We need to spell things correctly. Bane of my life. Changed. They wants a method name. It's because it's got volume again. We don't need volume, just need that. There we are. Dev Chatter, good afternoon. Good to see you. Surly Dev, good to see you. Yeah, virtual Surly Dev. It's just me all over, isn't it? Ace Flames here, welcome. Good to see you. You're watching me struggle through. Yes, I know it's got a spell check feature. It should be on, actually. Spell checking should be on. Yeah, it is on. It's switched on. Yeah, it is switched on. So I would have noticed eventually. Hi, Dev Chatter. Good to see you, Brendan. So yeah, you're watching me struggle through my very first WPF application. As I said earlier when we started, be kind to me. So now we should be able to call our onPropertyChanged here. I've never done this before. Surly Dev, no worries. You want us to be kind to you? Yes, please, Surly Dev. I know your reputation to be surly, but you don't come here to be kind. Well, okay, don't be kind then, but be helpful. If you know WPF, then give me some guidance. But I don't want to get hung up on the WPF side really. I'm just trying to get something basically wired up. Let's give that a go. So that should change those two properties, shouldn't it? So we should get, I think we want to set actually, we want a default value for volume as well. So I think we can set the volume here. Otherwise we're going to blow our ears off if we're not careful. So let's try that and see what happens. We go and build failure. I went to F after that. Okay, let's see what happens. So we're at 25%, and that should change, which it does. So I count that, and I could quite happily stop the stream here and say, there, I've done it, I've written it, but so dev chatter, call a member name. I don't know about that, no. So if you'd like to explain what that is, maybe we can include something along those. If that's a clever thing. So call a member name is that the name of the line 50. Well, actually on line 50 itself. In here or before the variable. Okay. What's that going to do for me? Let's make sure it's actually throwing up, but it's probably because we need to bring something in. Yeah. Compiler services. Yeah, bring that in. So it says it may only be applied to value parameters with default values. Okay. So you're saying there's a required using. I'm not sure. Let's give it a go and see what happens. So yeah, we're still working, so I'm quite happy to add that. Maybe you could remove the string volume. So I can remove that. Is that right? Yeah, do you want to line 25, yeah. Let's try it again. Still seems to work. Wonderful. Excellent. That just says, so basically what it's saying is that we've called it, it's been called in from the volume property, and so it just knows. But otherwise we can override it with we can override actually passing a value in. Okay, that's good. Excellent. That's good to know. So this is new in .NET Core 3. I don't remember seeing that property before. That attribute. Okay. Right. So the other thing we need to do is actually we need to it's been around for a long time, but you don't hear about it. Okay. Can you show that code again? I was busy Googling. So that was this piece of code here. Yes, I noticed the namespace for it was a compiler namespace, line 51. Yeah, line 51. It's on the screen now for you. Okay, so I'm just going to look at my notes and see what the next thing we need to do. What we need to do is we're going to need to have events for key presses. So we're going to use our computer keyboard, the bottom row, and some keys on the second row of the second row from the bottom of the computer keyboard to be our piano keyboard. So we're going to need to have wire up some events on key up and on key down. So let's do that. So that'll be over in the main window here, and we need to just implement. We need to override some events. So that's going to be protected. Override void of on key down, and that takes key event args E, not that. And we also need on key up. So the idea is when we press the key down, it's going to start a sound, and when the key lifts up, it's going to stop the sound. So DevChat says, yeah, so Dev says, does that call event handlers each time a certain property changed? And DevChat has replied, yes. It will set the value if you don't pass one, which is really quite useful, isn't it? Makes it that when you call the method, you don't have to pass the parameter you don't want to. It just passes in the name of the member you're currently in, which in that case was it was the volume member, but obviously we had to kind of also change the volume, so we passed that in. Do I want some WPF advice from the back seat? I don't really want to dwell overly much on the WPF aspect of it this time. Maybe we could continue that in Discord. I do want to get onto the actual digital audio part of this, and this is a bit kind of a bit of a setup really. So I do appreciate any advice you can give me. If it's kind of if it's something short and sharp we can actually implement, fantastic. Otherwise, I don't want to get too hung up on the WPF aspect of it. So we do need to call the base here, don't we? The base dot on key down. Pass E into that. We're going to then need to call a method on our. You're going to suggest using a command binding instead of event handlers. Okay, I've got some command bindings on the main window. I've got these command bindings on the buttons. Oh dear, what happened there? Sorry, silly Dev, something really weird happened there. So backlisted spam, sorry about that. It's just that Nightbot's really turned up. So I do apologise. I'll sort that out for you and give you a VIP. So it should, yeah, yes, yeah. Maybe I've been a bit overzealous, perhaps, with the settings on Nightbot. I will kind of dial it down. No, not going to. I'm not going to use these commands for the key. They're just for these two buttons. So I understood that kind of concept. So with these, I do really want events. I think I want events. So when we got something that which creates some sound, perhaps we could have another look at it. Because it's not just a command on the key on pressing. It's not pressing the key. It's actually the length of time the key's down, and then when you lift up, and eventually we're going to build in kind of sound envelopes, and the point where you kind of press the key down and lift the key up are quite important. So I don't know if it's not just going to be a command. Is like when you press B, it's the fact that B is still pressed down. So I'm not sure. Very good, silly Dev. Okay, so on key down, and we want to then going to call a method on our view model. What should we call it? Key down. And then we'll do the same thing over here. Yep. We're going to define those over in our view model. So it's going to be up here. So we're going to have private, public rather. So let's move them above the private methods. So public void key down. That takes key event args. That takes key event args. And we want to key up as well. Okay. So we're almost wired up. So that's all okay, I think. We've got the basic UI that we need to the first stage of this project done. Our main window, we set the data context up. We've got the two events built. DevChatter last streamed 9 days ago. Yes. Are you planning to stream tomorrow, DevChatter? Good question there from Ace Flames here. We do miss you. Okay. So what do I need to do next? I need to have a look at this line here. Okay. Should be streamed tomorrow. Great. Wonderful. So we miss the DevChatter stream? Definitely my favourite stream. Okay. So I think what we need to do is define the keys that are going to actually comprise our keyboard. So let's do that next. So let's create a private read-only. It's going to be a list of keys. So key should be available to us as a type, which it is. And it's going to be called keyboard. And that's going to be a new list of key. And we can use a list initializer here. So this is going to be so the way I think this is going to work is that we're going to start off with the Z key, and the Z key is going to be the note A. That means that when we work up that the C key will be the note C on our piano keyboard. So that should work out nice. So if we set the key 0, remember that so a bit of kind of, it's not really music theory, but when an orchestra tunes up, they tune up in the key of A, and they normally tune up in what's called concert pitch, which is in music is called A4. That's 440 hertz, I think. So we're going to have a multi-octave keyboard, but actually only going to have about one and a little bit octaves at a time. So we're going to be able to change our octaves eventually. So we're going to start off with a low octave keyboard, and then we're going to be able to switch it up to a high octave. So our first note is going to be A. That's going to be note 0 on our scale. So we're going to start off with, say, note A2, which is 110 hertz. And so that's going to be the first key in our list, because that's going to be key 0. That's going to be key Z, okay? So the next key, if we go a semitone up from A, we get A sharp. So we need to go up onto the second row of the keyboard. That's going to be key S. So that's our black key, basically. And and then we're going to go to key X, which is going to be the note B. So there's no black key between a B and a C, because there's only a semitone between a B and a C, if you know your music. So now we've got C. Key C is actually going to be the note C in our octave. Then we have a C sharp, and confusingly that's going to be key F, if I'm looking at my keyboard correctly. And then we're going to have D, which is going to be key V. I also say I'm not a pianist. I do play the guitar a little bit, but I'm not a pianist, so I'm not going to be able to play really great tunes on this. But we might get a few chords eventually when we make this keyboard polyphonic. But initially it's going to be monophonic keyboard, so only one note at a time, no two notes playing at the same time, no chords, nothing like that. So polyphony, I've got an idea how we can do it, and we'll have to see if it works when we come round to that. It's probably next stream or the stream after when we get to polyphony. Hopefully next stream, depending how far we get today, because we've been going for just under an hour now, and we still haven't made a sound. So we're up to key V, that was D, and we've got D sharp, which is going to key G, and then we want what was I saying with key V? No, key V, key F, sorry there. So, no, it's not key F. It is key G. That's D sharp, and then we want E, which is going to be key, confusingly B. Okay, so that's as far as the E, and then we're going to F. So there's no semitone between E and F. We go directly to key N. So if you look at your keyboard, you'll see that we've missed out H. H is not going to be part of our keyboard. Then so we're on F, under F sharp, which is going to be key J. Then we want a G, which is going to be key M. Then key G sharp, which is going to be key K. Then we're going to go down to A, which is going to be the comma. That's key OEM comma. There. That's an A, it's an octave above the A, which is on the Z. The A sharp is going to be key L. And then key B is going to be the full stop, which is OEM period here. That's B, and then we're going to go up to C again, which is going to be key OEM, and this is the question mark. So that should be our full list of keys. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 keys. That's right. So we've got a 16 key keyboard. Whereas C sharp, C sharp is the same as C sharp is there. So C sharp is key F. If you have to B sharp, that's key C, which is the same as C. Okay, that's our keyboard. So what do I want to do next? Okay. So it's time to start looking at a bit of programming the sound. Okay. Okay. So now we need to go over and have a look at N-Audio. So this is the library we're going to be using. ASG, welcome to the stream. Good to see you. Oh, C sharp. Okay, yes, very good. I'll get you now. So this is the N-Audio GitHub. You can see on here, this is it's a very extensive library. A lot of it is to do with playback and recording of audio. We have codecs, so we can do compressed audio. We can also do mixing and manipulating of audio streams, and this is what we're going to be concentrating on. playing back and recording and playing back audio is really kind of not that interesting. But this section here, which is manipulating audio streams and particularly constructing a signal chain, is what I'm interested in actually exploring, because then you can look at metering and waveform rendering. So we can look at the waveforms we create. We can do some fast Fourier transforms, so we can do some spectrum analysis. Yes, it is, DevChat, you're right, an awesome library. We can do some delays, loops, we can do EQ work, and we can do effects, basically. So that's the kind of area I want to kind of concentrate on. And it's this ability for us to build signal chains, which is like hooking your... so a signal chain, basically, Silly Dev, if you've ever seen a guitarist, they kind of play their guitar, their electric guitar, and then that goes into a maybe a tuner where they can see if their guitar's in tune. It might then go into a delay loop pedal, so they hit the pedal and they get an echo. And after that, they may have a compressor, which kind of changes the volume. It evens the volume out of notes. They may have something to make their a nice dirty kind of guitar sound, so the kind of heavy rock kind of sounds. So that the way you have your effects pedals as a guitarist laid out, your guitar goes in one side, and then you have a chain of effects pedals, and eventually you plug into your amp. So so that's a signal chain really, but it needn't be a guitar. It can be any kind of audio source, and passing through various software. In a guitar pedal, obviously it's an electronic effect, so it's done by electronics and with computer software in there as well. Here we're talking about purely software effects, and the interesting ones for us at the moment are going to be controlling the volume and also mixing signals together. So when we have a polyphonic, just kind of to skip ahead, my idea for a polyphonic keyboard is to use a mixer, and then basically what happens, we have multiple signals going into the mixer, and the mixer creates a single kind of audio signal from that, and then we put a volume control in front of that, so that then we can control the volume of the mixed signal. As we're going to build it now, it's going to be pretty crude. It's going to be monophonic, and we're going to actually generate the tones in one class, in one oscillator class, and we're going to basically, when you press a key, it's going to switch on that oscillator. When you lift the key off, it's going to switch the oscillator off. So it's a bit crude, really. But this idea of signal chains is going to be really important. And what N-Audio provides us to create signal chains is an interface called iSample Provider. And what iSample Provider is going to allow us to do is to create these signal chains. We're going to pass these samples, the sampled audio, we're going to pass it from effect to effect. And also the effects could be kind of monitoring effects or visualizations, or actually kind of adding echo and delay and compression, all that kind of stuff that you get in a guitar effects pedal chain. And also when you've got a digital synthesizer, then you get all those kind of controls on there. And we're going to have some controls. We're going to have some kind of knobs that we can fiddle with eventually and change the sound that we make. So I think we better start off by having a new class. And we're going to call this synth wave provider. So it's going to create a wave. Synth wave provider. Yeah, that'll be right. We'll make that public. And we're going to inherit from. We're going to inherit from iSample Provider, which is the basic building block for creating these signal chains. Now we haven't brought in N-Audio yet, so let's do that now. So search for N-Audio, and here we are, Mark Heath, N-Audio, 1.9, 750,000 downloads. It's also got some other extensions other people have done, but we're just going to have the basic package. Okay, there we go. Right, let's bring the right package in. So we're bringing in the NAudio.wave namespace. Now, NAudio provides a number of wave providers. The signal generators, all kind of things in there, which we can create sine waves and saw waves. But we're not going to use that. We're going to use a different technique for creating our signals. We're going to use what's called a wave table, otherwise known as a lookup table. So we're going to create like a single cycle of a wave, and then we're going to use the samples from there to actually create all the sounds that we're going to generate. The iSample provider interface is really simple. Basically, you have a wave format and you have a read method, and this read method should look quite familiar to people who work with streams. It's basically very similar to the read signature of a stream, except rather than an array of bytes, we're getting an array of floats. And this is the important part about signal chains, is that we're going to actually use 32-bit floating point numbers in the range of +1 to -1 to represent our signal. So that's the sample range we're going to have. Because they're floating point numbers, obviously we have a huge kind of huge number of values which we can fit in between plus and -1. So we're going to get very high fidelity really, and we're going to create our wave table at that kind of resolution. So it's going to be pretty good, and we're going to use kind of CD quality sampling rates. So CDs sample at 44.1 kilohertz, and we're going to use that same sample rate. If you're confused by any terminology I use, I only just learnt a lot of this terminology over the past few days when I did some courses. Now, Mark Heath, whose package this NAudio is, he's got some courses up on Pluralsight. So I did the Audio Fundamentals course, and I'm about 3/4 of the way through his NAudio course. So I'm learning all these kind of terms, but you can use the ask command in with the bot to ask questions. So I can put in, for example, what is sample rate. Let me just type that in. And we'll see if it comes back with any kind of sensible. There you go. So it's in chat now. You should see a simple definition of what sampling rate is. So it's the number of times we're going to sample a continuous signal and turn it into a digital signal. So obviously a sine wave, which will start with a sine wave, that is an analog thing. It's continuous, but we're going to sample it. We're going to take readings every so often along the whole single cycle of that wave, and that's going to be, our sampling rate is going to define how accurately we kind of can reproduce a sine wave, basically digitally. Okay, so we've got our we need the constructor now. So public synth wave provider, and we're going to take in a sample rate, and we're going to default it to 44100. So 44.1 kilohertz is going to be our default sample rate. And what we'll do is we'll store that. Oops, not what I wanted to do. Okay. So we've got our sample rate. So we're going to want to pass in what frequency that we want this wave to be, the sound to be. So let's have a frequency property. So we have a property called frequency. Okay. We want a volume, don't we? So we'll have a float called volume, because we need to pass in what the volume of from our control. We need to pass in the volume of our that the wave's going to be played at. Okay. Frequency. We'll have that as a double rather than a float. In fact, what we'll do is we'll make that into we'll expand that out. And we'll have frequency like that. And return frequency. I have a set. We should be okay. We shouldn't need to do this. We should just be able to have. We should just be able to have a getter and setter. So let's not worry about that. Okay. I was just thinking of something else we might want to do with frequency, but I don't think we need to do any kind of notifications. We should just be able to use it. Okay. So now I'm going to I've got a piece of sample code in front of me, which is basically so I went on to the N-Audio site and I looked in one of their samples. And where would it be? Good question. Where is it? There's lots and lots of demo applications that come with come on the website here on the GitHub. Not in WPF demos. Anyway, I've got some code in front of me which I'm going to use to help me kind of write this. What's it complained about here? What did that change to? That's volume. That's weird. That's strange. Okay, never mind. We're working over here. So we've got a volume property which we can alter the volume and the frequency of our signal. Okay, so we've got this wave format here. Let's put a getter on that. Right. So the wave format, it basically is going to be a definition of what the file format we're going to write our wave in, and we're going to use the WAV file format, which is all familiar with WAV files. But we're going to okay, so WAV files are usually written as integer values. So the samples within a WAV file are integers, but we don't want to use integers. We want to use floating point. We don't want to go between maximum int and the maximum short and the minimum short in our full amplitude of a wave. We want to go from +1 plus 1.0 to minus 1.0, which is basically we want to use floats for that. And the reason why we use floats is that iSample provider is going to want a float buffer. We don't need to fill up a buffer with floating point numbers. So if we look at some of the code that I've got written down here, so the first thing, we need to define how many channels that we're going to have of audio. And we're going to have one channel, and you'll recognize that's mono, so we're not going to be outputting in stereo. Okay, so one channel, and all these, the sample rate and the number of channels, those things are really important in determining what the wave is going to look like, and how what the wave format is going to be created. So we're going to pass in into a method in a moment the sample rate and the channels, so it can kind of create the definition of what the wave format will look like. We never have to use it ourselves; it's used internally, but it basically defines the sample, the wave file information that goes inside the wave file format. If we to save this sound to a file, it would be there. Must resist. Fuel Stable, welcome. T4, yeah. Don't mention T4. Okay, so we're going to have a volume. Set the initial volume, and we'll set the volume to 0 initially, just so that it'll be controlled externally. But yes, hi Fuel Snowber, good to see you. Thank you for the stream on Monday. I really enjoyed it, and as I said in Discord, we think we're quite a good double act on that stream, so I enjoyed it. So then we want frequency, and we're going to start off oddly with a frequency of 0, and there's a cunning plan behind that, which I'll come to. So our wave format, that's going to be so we have a class called wave format, and on there's a number of static methods, and there's some create float. So there's a number of kind of things you can do. Create custom formats. There's MULAW. There's all kinds of stuff if you're really into your audio. MULAW formats, whatever. We want this IEEE float wave format. So this is going to define the format of a floating point wave, and we need to a digital wave which is going to be sampled using floating point numbers in the range of 1 to minus 1. We need to pass in the sample rate, so that's going to be 44.1 kilohertz, and we need to define the channels. And what that's going to do basically is it's going to determine what the wave file layout is going to look like inside, or how bits and bytes are going to be kind of distributed in there. It's not a very good example, but so Fuel Stable says, when you see devs implemented iNotify property changed. Yeah, sorry about that. You want to use T4. So you enjoyed the stream? Good. I'm glad you did, Fuel Stable. It was great. You've asked the team members to rate it for you. Well, yes, you can pass the rating on to me, because it's obviously it's nothing to do with you how good or bad it was. It's all be down to me. So okay, so that's our wave format. So we haven't got to worry about that too much. Basically, we've defined that. The next thing we need to do is to actually create a wavetable. So our wavetable is going to be an array of floats. So it's going to be defined what our buffer is going to be filled with. So we need a wavetable. So it's a float array, and it's wavetable. Okay. So wavetable, basically it's a lookup table, so we'll be able to go along and at any point look up and see what the floating point value of the amplitude of the sine wave, or whatever kind of wave we create, is at that point, at that index. So for example, we're sampling at 44,100 samples per second. If we go half a second in, we'll be looking at a point of 22,050 indexed into that wavetable, and then we look at and read off what the amplitude of the wave is at that point, and it should be like 0 really at that point, because we're halfway through the sine. If it's a sine wave, if it's not a sine wave, it could be anything. But if we're going to start off with a simple sine wave, okay, so that's what the wavetable is going to. We're going to build a wavetable which basically contains a single cycle of the wave. And as I say, the floating point range is going to be +1 to -1. So our wavetable is going to be a new float array, and it's going to be of length sample rate. So if we've got a 44,100 samples per second, we want 44,100 samples in our floating point samples in our array. Okay, so now we need to fill that. So we're going to go as far as sample rate here. We're going to increment like that. Okay, let me just get rid of this panel here. You can see more code. Okay, so let's do a sine wave. So wavetable oh dear me, my typing. Okay, so there's got to be floating point numbers. Okay, so it's a simple sine wave. So math.sine. Okay, so you'd have to take my word for it. 2 pi times I divided by the sample rate. I divided by the sample rate. Okay. Now we've got some problems. Oops. We'll have some problems here with our math. So this is going to be the whole thing needs to be a float. No, wrong. The whole thing needs to be a float. So we need to convert it to a float here. Okay. That's an integer. That looks okay. Yeah. So that is a kind of a unit sine wave. So that should generate our wavetable for us. Right. Now, when we read the wavetable, what we're going to want to do. Okay. Right, we need to define a few more values. We're going to define doubles. What's the best thing to do? Private double. We're going to call it phase, and a private double phase step. So you'll notice that we're creating a single cycle of the 2 pi is 360 degrees. Yeah. So we're going. So a sine wave basically is going. It kind of if you think of it as something going round in a circle, and it moving along as it's going round in a circle. So a pen circling a point. and the radius to the pen from the point in the center is 1, and then you move that whole thing along a piece of paper at a certain speed, then what the pen is going to draw out is a sine wave. Yeah, that should be underscore sample rate. You're right. Yeah. So it's obviously there's no variation in that wave. It's just it's a constant frequency. It's basically 1 hertz. But in order to get different frequencies, we need to basically read through that that wave table in a different way. We can vary what it produces. So we're going to say that a phase step is going to be the length of the wave table which, as we know, is the sample rate. That's 44,100. So I do admit that I am looking at notes at this point, because remembering this is a bit difficult. And we want our frequency divided by the sample rate of the form. We can get that from wave format. Got sample rate because we've set up our wave format here with our sample rate, passed it in there. So strictly speaking, we don't need to have it as a value up here, and we might get rid of it. We've got our phase step. Okay. Now we're going to read the buffer. And we're going to read as far as count. So what's going to happen is that whatever's going to read this buffer is going to ask for a certain number of bytes, and we're going to kind of give it those bytes. Pure Stable, why is there a wave table? It's just the way I want to actually do this. There's some advantages later on to using a lookup table for our wave samples. So Pure Stable is a float, put phase and step are doubles. Yeah, they're doubles in my notes. I think it's okay. So this bit is this bit I'm having to work from sample code that's in the N-Audio, and I'm still working my way through the digital audio course. So maybe I'll know the answers to all this at some point. But at this stage, all we're doing is trying to convert our wave table, the samples in the wave table, into samples which is going to be read by a consuming application. So in this case, it's going to be an audio player which is going to read these samples and convert them into sounds. And this is the way that that this kind of read method is kind of central to everything that you do in N-Audio. When you're coding at this level, this is going to be the source of all the samples that we're going to use in our signal chain later on. So we're going to change them, we're going to mix them, we're going to alter the volume of them, and that's how that kind of thing's going to work, really. So that's a bit vague for you. I don't know. I know that you want me to give you exact definitions for these things, but I'm not able to do that just yet. I'm still working on that. Okay, so okay. We got our frequency in there. So basically, we're going to this is what the phase is going to be. So we're going to read. We're going to work out what the. So that's not a multiplication. That's a modulus sign. this is how we're going to shift frequencies. Basically, we're going to read at different. We're going to use this phase to read the wavetable at different points, and then that'll be our frequency shift. So that's that. So buffer. So let me get this code written, and then we can investigate what it's actually doing. So we need an offset. And we've got offset here. Offset comes in. Okay, good. That's going to be. So this is where we're going to grab the sample out of the wavetable. So wavetable, and we put in the wavetable index in here. So we pull it out of that point, and we're going to multiply that by the volume. So remember, the volume is going to be between 0 and 1. So we're going to only change the amplitude of the wave that we're reading out between 0 and 1. So at full volume, it's going to be the full length of the wave, the full amplitude of the wave. Tanks Live, thank you for the follow. Wonderful, great, Mr. Magoo, sequel Mr. Magoo, welcome. Live 27. Yeah, basically we're going to tidy all this code up, Mr. Magoo. Basically, what we're doing is trying to get the basic stuff working. So this is taken from sample code. There's lots and lots of stuff we can do to make all this nice and neat. So don't worry about it at the moment. Let's just get. I'm trying to get a sound. Once we've got a sound, there's a whole bunch of refactorings that we've got planned as we start adding features to the synthesizer. So now we need to just move the phase on. So the code I've got written down here, for this read method, is not what I'm working with. It's just it's from another project in the sample code, which is why I'm sometimes talking the right thing. I don't want to copy exactly what it's got down here. So then we need to make sure that we haven't stepped outside the bounds of the array by doing that. So if phase is greater than wavetable dot length, then phase minus equals length. Okay. And then at the end of this, we need to return count. And if we ever return 0, then playing of this sound will stop. However, what we're going to do, we're going to have a continuous sound, and we're just basically going to change the frequency to 0, and that, obviously a 0 frequency sound is silent. Lookup tables are not so 1990s, Stable. Yeah. We can certainly build there's generators that we can use within N-Audio to create sine waves, saw waves, triangle waves. But this wavetable way does give you some advantages. Okay, so we've got some basics there. I think that's pretty much what we need. Okay, let's see what we can do with that. So I can put my crib sheet away there for that code. So what we're going to need to do, we're going to need to actually create one of that class. We need an instance of that class. So we're going to create, what should we call it? Let's call it wave generator, oscillator. Oscillator. And this is going to be a synth, type synth. In fact, we'll just say it's a type iWave. No, we can't call that. We need all the methods on synth wave provider, and we'll call that oscillator. Okay, and then here we can say oscillator is a new synth wave provider, and we just take the default sample rate, which is the CD sample rate of 44.1 kilohertz. So there's lots of conversation about the merits of lookup tables going on. So that's fine. You carry on. The idea of the lookup tables will generate. Eventually, we're going to generate one lookup table and then pass it around multiple oscillators, which is why I say there's a reason why I wanted to do that. That way, we calculate that array just once, and then all the samples never change, and that we can pass that array around, which is why I got into the lookup table. Otherwise, every time you create the oscillator, you'd have to kind of evaluate the sine wave function, and I didn't want to do that. It's just that we're just not there yet, and there's a number of refactorings which I've got in mind because of the way I intend to create a polyphonic keyboard, and the way I intend to create a polyphonic keyboard is to have an oscillator per key, because there's some distinct advantages to doing that, and a lot of kind of the early actual physical synthesizers work that way. So it's not it's not an outrageous thing. So Fuel Never says, I think that it's a valid reason for using lookup tables, but for performance they're not getting less relevant. Oh, that's certainly true. I mean, that's the kind of the CPUs these days. It's not actually it's not a big thing. Okay. So when we switch this on, we're going to want to so we want to do the on command. When we switch our synthesizer on, we want to create a player, something that can play our sound with, and we're going to use a class. We're going to use a class called a wave player. So a private iWave player. So this is something which we kept from NAudio, and it will play, as it says, wave files. And you remember that basically we're going to generate our samples in a format we can pass to this wave player as if it was reading a wave file. That's what our IEEE wave format thing that we float wave format that we created earlier. So wave player. We need to bring that in audio.wave. We're going to call that player. Okay, so when we switch our device on, what we want to do, so if player is null, so we haven't created one yet, then in order to pass our samples into the player, we need to create a class called WaveOut. This is another NAudio class. There's a couple of variants on this class. We're going to use a class called WaveOutEvent, which basically means that rather than using the GUI thread to read the buffers that we've created, remember we've created this buffer that it's going to be reading from, it's going to use a background thread to do that. So that's why we've chosen to use this WaveOutEvent class. can see there's a wave out event class here. Okay. So what we need to do is define in the wave out event properties here. We need to define how many buffers we want it to read from. So we can have any number of buffers. We're going to choose 2 buffers, and then it's going to fill and read from these buffers on a background thread because we're using this wave out event class. If we just use the wave out, it wouldn't do that. It would just do it on the current thread, and we don't particularly want that to do that. You know, a program that's very into synthesizers, Linklumps. How many episodes I'm going to do? There's going to be at least 3 or 4, maybe more. It depends how far I get, because we're now coming up to an hour and 3/4, and I haven't made a sound yet. So, so who knows? But yeah, 3, 4, 5, something like that. I don't know. It depends where we take it. Once we get past kind of creating a polyphonic keyboard, then we're going to want to put kind of sound envelopes over that. And then we're going to try and create different instruments, perhaps. So we might, try and create a church organ sound, and then maybe a more electronic organ, and just try and get different instruments. Who knows where we take it? It depends what kind of skill I've got in trying to digitally recreate the voices of instruments. But we'll try and get some different sounds at least. So just to kind of say that the idea to produce a synthesizer was actually taken from a guy called JavidX9. I'll give him another shout out. I did mention him at the start of the stream. So he, when I was looking for what I could actually use with N-Audio, I did check out his streams. He does C++ programming, and he created the synthesizer. So we're very much kind of following in his footsteps, but I'm taking a completely different kind of route. We're not using C++. We're using .NET Core 3, WPF. We're going to have a GUI. We're using wavetables. We're using different technologies really than he did. But full disclosure, he did that piece of work and kind of inspired me really to do this. And the next thing we pass into here is our desired latency. Obviously, our latency we want as low as we can get, but my sound card isn't a professional sound card. It's probably a pretty good sound card because I've got an expensive gaming rig here, even though I don't play games on it. But we'll choose 100 milliseconds of latency because that's a reasonable figure. Our sound cards certainly can handle that. If we start to lower that, we could get kind of clicks and dropouts, and I'm not really bothered. I'm not going to be playing so fast that it's going to worry us. So that's our desired latency. So it's a reasonable latency. Okay, so we've got our wave out event. Our player is going to be that wave out event. I might have this blank line between there, and we're going to initialize it. Player.init. So there are a number of kind of things you can set up in your wave out event, but as soon as you initialize it, then those kind of those configuration options are kind of set in stone. So you have to set things like your buffers and your latency and anything else we want to set up before we call init. In init, we're going to create a new sample to wave provider. Provider, and in there we're going to pass in our wave provider. What did I call it? Oscillator, didn't I? So we need to bring this class in. So what we're doing here, so when we play wave files, they're actually 16-bit integer samples in there. So they rather than going from 1.0 to -1.0 floating point 32-bit, your wave file is a 16-bit integer, and it goes from the maximum value of a short to the minimum value of a short. So this sample to wave provider basically is an adapter. It's taking in 32-bit floating point samples, and it's turning that into 16-bit integer wave, which our player can play. And then we can simply say player.play. In our off method, we have a similar thing. We can say if the player's null, then we can simply return. Otherwise, we want to call dispose on the player. And set the player to null. Okay. In fact, what we'll do is just do this. Okay, so I've got a note here in my notes that it basically says that this is quite important to dispose of your player, and when we close the main window, we want to make sure that we do dispose of the player. So in my main window XAML.cs here, what I want to do is add a closing event on here. So we're going to subscribe to the closing event. And once again, I'm going to have to copy this. Oops. So we're just going to call viewModel.offCommand.execute. Pass it into that. What's it complaining about? No, we're fine. Nope. Closing. There we go. So that's basically what that's going to do. Is if we kind of hit the X to close our window, it's going to run the dispose. It's going to run the off command, which is dispose of our player. Okay, so that's that bit. Let's see. We can make sure we compile still. Should do. Yeah, we're safe. So we haven't tested anything yet. It's a bit like our coding session on Monday with FuelSnable, when everything just kind of worked. It was magical. That's the kind of magic of functional programming. We built up our parser combinators from first principles, and it seemed that we couldn't really get them wrong, which is quite interesting. Okay. So now we want to do something with our key presses. Okay. So so this is going to be pretty crude. We're going to set the frequency of our oscillator whenever we press the key. So different keys are going to rewrite the frequency of our oscillator and change them. So we're going to have one oscillator, and we're going to change the frequency of that oscillator depending on which key we pressed. Okay, right. So let's first detect our key presses. So so we can say something along the lines of if keyboard dot index of e.key greater than 0, greater than -1, isn't it? Greater than -1. Then we pressed a key. It's not that keyboard, it's that keyboard. So we've pressed one of the keys we're interested in. Okay, so let's grab the value of this first. So key val is going to equal that. So if key val is greater than -1, so that's going to return us a value between 0 and 15, isn't it? So 16 keys on our keyboard. Key 0 is going to be key Z, and key 15 is going to be the question mark. And key Z is going to be the note A. Okay. So we want to play the note. Right. So I'm having to think now about how we're going to exactly do this. Okay. Okay. So frequency. So let's have a look. Let's go back up here. So the volume here. The volume's not right, is it? We need to get the volume from our oscillator. This is going to be oscillator.volume. How comes that's... I'm a bit confused by that. Oh, I think we somehow we're linked in, aren't we? That's what it is. This is CodeRush helping me out. It's oscillator.volume. If the volume is equal to the value, we didn't change it. So what we're trying to do is change what's going on. We're trying to change the volume on the oscillator. So that's the best way of doing that. So if the oscillator.volume is equal to that, I'll allow a volume, then return, otherwise oscillator.volume is equal to the value, then we don't need this anymore, because we're not really interested in holding the volume. The volume we're changing is going to be the volume, and we want to, I don't like that, so I'm going to put braces around that. So yeah, so that's going to change the volume on the oscillator. That's good, that's what we want. The frequency on the oscillator, we need to change the frequency on the oscillator. So if we go back to our synthwave provider, you notice that when we initialize when we create the oscillator, its frequency is going to be 0, which means it's basically going to be playing silence. Is this FM synthesis as a basis? We're not going to be doing frequency modulation at this stage. Actually, frequency modulation is one of the things I'm not sure how to do with a wavetable. which is why we may end up moving away from wave tables in the end, as Fuel Stable has kind of pointed out. We may generate the sine waves or whatever waves on the fly. So I'm not so up on digital audio terminology that I understand what FM synthesis is, I'm afraid, Link Slumps. So let's ask the bot, what is FM synthesis? So frequency modulation synthesis is a form of sound synthesis where the timbre of a simple waveform, such as a square, triangle or sawtooth, called the carrier, is changed by modulating its frequency with a modular frequency. That's okay. So yeah, so that will be when that's when we get into things called low frequency oscillators, where we can have some kind of vibrato on the notes, so that there's a slight change of frequency. It's a bit like when, as a guitarist, you apply vibrato by rolling your finger, or same with a violinist. They move their finger on the fretboard like this, and it kind of varies the frequency of the note slightly. You get the main note, and then you get the variation. The frequency they move their finger is the kind of low frequency oscillator, which is modulating the sound. So that's where you get that vibrato sound. So we do want to get that eventually, because our synthesizer should have the ability to produce vibrato notes, have that wobble on the frequency. But I'm not sure how to do it with a wavetable, if I'm perfectly honest. So we're not going to have low frequency oscillators for quite a while, and frequency modulation is something a few steps down the line, I think, and we'll figure out how to do it. Okay, what I was saying is the frequency is going to be 0, which is basically silence. We need to change the frequency when you put the key down. On key down, we're going to set the frequency. We've got frequency here, haven't we? So we need frequency. Maybe frequency. It can be a double. Okay. So here we're going to return the frequency of our oscillator. Yeah, stop it. So we've got kind of areas that have been highlighted here. We need to press escape there, and then we can change it, I believe. The frequency of our oscillator. Dot frequency. Yeah, we can grab that and say that and that. And I don't think we need on property changed. And we don't need frequency up there either. So now we've got a frequency property which we can vary. So frequency is going to be equal to, okay, so this is where we need to do a bit of maths. Okay. We're going to do a formula. Have mercy. So we're going to do a formula. So how do we calculate what the frequency of the note is based upon what the number of the note is? So is it note 0, which is ZA, or is it note 1 to note 3, which is C? How do we calculate that? Well, there's a formula for doing that, and that's basically F sub n. So the frequency of the nth note is going to be equal to a base frequency. So we'll call that F sub b. And then we're going to multiply that. And we're going to multiply that by the square root of 2 to the power, the 12th root, sorry, of 2. And we're going to raise that whole thing to the power of n. I'll step away from that. Okay. So basically, n is the number of the key in our array. So the 0th key in our array is the Z key, and that's going to be A. So here n is going to be 0. Anything to the power of 0 is 1. So the frequency of that note is going to be equal to our base frequency. It's not a Fibonacci sequence, no. It's basically it's definition of the frequencies in an octave, basically. So we need a base frequency. Let's create a base frequency. What we're going to do is we're going to make it a property. And we're going to make it a property because later on we're going to want to be able to control what the base frequency is, so we can shift octaves. So we'll make a float and we'll call it base frequency. Okay, for the moment we're just going to have it return. We'll fat arrow that to 110.0 as a floating point number, and that is the note A2. And then we want the 12th root of 2. So private float. We'll call that 12th root of 2, and that's going to be equal to, so we did calculator. Scientific. So we've got root n here. We haven't really got square roots. Oh, wonderful. Scientific calculator hasn't got. Okay, let's go and look on the internet. Root of 2. Is it going to tell us the value of the 12th root of 2? This is the formula that we're using. You can see that the base note A is 2 to the power 0 over 12, 1 over 12, blah blah blah, all the way up to a full octave, which is just double. So basically, the base note, the base frequency times 2. So we could use this, couldn't we? Divided by this value here. Okay. So our frequency is going to be our base frequency multiplied by 12 root of 2 times the math.pow 12 through to 2 and keyval. So that should set the frequency of our oscillator. Okay, let's give it a go. See what happens if we press the key and what happens. We didn't create oscillator. So that's got to be equal to a new synth wave provider. Okay, let's try again. So Fuel Snowball, you say, can you commit the latest code? I want to take a stab at the view model. You don't have to accept the PR. Yeah, we'll do it. So as soon as we've finished, I'll commit it. You better have a play, and do feel free. Anytime anyone submit PRs to any of my projects, please do. So let's put the volume up to. Interesting, the volume didn't quite work there, did it? Okay, can you hear the tone? Can you hear that tone that's playing? So it is playing a note. Unfortunately, I've got my hand off the keyboard. It's still playing the note. Is it loud enough? Loud enough, guys, that we can actually work with that. Put it up to 50%. Okay, great. It's a hum, yeah. So that's a sine wave, boring note in there. So turn it off. Okay, so we've got it to play a note. So what we want to do is to stop playing a note. Let's just tidy that up a bit. Okay. So on key up, we want to get the value of the key again, and we can tidy all this up later. I mean, let's get it so we can play a note because we're approaching when I've got to stop. If the key value, once again, if the key value is greater than 0, then we want to set the frequency to 0. Make it quiet again. Let's just go into our synth wave provider and set the default volume to 25 because it was set to 0. Okay. So switch on. I'll put the volume up a bit to 50. So let's play an A and a C. So A, B. We have sounds. A tune I like, but I don't know what I like it. Thought of listening to the hum of a Ich bin meine Maschine. Yeah, is that something? Is that Kraftwerk or something like that? So we've got. Let's play a full kind of scale. Well, we've got to. That was A. So we've got a synthesizer. It's not a very interesting synthesizer, but it does do something. So let's just do a bit of variation. Let's have the sound wave is just too pure, isn't it? It's a bit boring. You wouldn't think it raw and raucous with a synthesizer. So let's just alter the what our synth wave provider is producing. We're creating a wave table here. Let's just comment that out. Oops, didn't mean to do that, did I? Comment that out. Just copy it again. And what we're going to do is create a square wave. So what we can say here is that if that value let's just wrap that in a, if that value is greater than 0, then we're going to output 1.0f, else we're going to output minus 1.0f. So that's going to be a square wave. So it's not going to have any slope. It's going to be either fully on or fully off. And obviously we're going to want to kind of build our front end so that we can choose what kind of wave we output, but that's going to be a square wave. Let's see what the square wave sounds like. Yeah, machine on. Like a Commodore 64, yes, it's a retro kind of sound, isn't it? But it's a bit more interesting than a sound wave. So it's a square wave. And there's other kinds of waves we can create. Let's switch off and try another type of wave. Let's comment that out. We can stick with our sine wave if you like, but we can make it a bit more interesting. We can start adding other sine waves to it. So what we could do, we could say, we'll take this sine wave, and we'll add some harmonics to it. So rather than 2 times that, we'll take 4 times that, so that's a harmonic, and then we'll have 6 times that, that's another harmonic. So it should make it a more complex waveform. We've got two, you've got the fundamental, the tone, and we've got 2 harmonics in there. Let's try that. So it's a bit more interesting than a plain. We could add even more harmonics into that, I guess. Let's try a few more harmonics and see if it makes it any richer. But it's still a bit boring as a sine wave. It's not very electronic. Let's add another harmonic above that, and then another one. So making the waveform a lot more complicated. So we've got a monophonic keyboard now. You know, it's not that great in that, like, if I press one key, so I press the C key, and I press V, and I release C, then there's that break. We want that to be continuous. And sometimes I press the key and I get no sound. And you can also hear, I don't know if you can hear it on stream, but when I press a key, just as it starts, there's a click. And when I stop as well. Yeah, so the square waves for you said, well, are better, aren't they? They're nicer. There's other ways we can try. So I've got the formula here for a saw wave. So let's try a saw wave. So wave table I is going to be equal to it's going to be a float of I divided by the sample rate. So this is going to be a saw wave. So it's going to look like the edge of a saw. So it's going to go up, and then as soon as it hits the maximum, it's going to drop straight down to the minimum. So and go up that way. So if you have a look at the saw wave, let's do a search for saw wave. Sawtooth wave. It's like this. This is actually a bit more interesting than our sawtooth wave. This has got some variation. You can notice if we can zoom in on this. It's got, so you can't really. it's got some modulation on these upward strokes, but we're not going to get that. We've got basically a very mathematical saw wave. Now you can create saw waves by adding lots and lots of sine waves together, and I'll dig out the mathematical formula for doing that. Here's a sawtooth wave. Let's make it a bit louder. This is like a buzz saw basically. And that's a bit more kind of synthy, a bit more electronic, and I hope you can tell that we've got our frequency formula right, because that actually was playing the scale of C there. So it's not a triangle wave. A triangle wave is actually like triangle, so it's this is a sawtooth, so it is kind of it's got a slope up, and then as soon as it hits maximum, it drops vertically down immediately in no time to the minimum value. So it's slightly different, but yeah, we can have triangle waves as well. So these different kinds of waves are what gives the kind of synthesizer its character. Let's switch off. I think I quite like the square wave to kind of leave us with, and the square wave was that one there. Let's play that once again. So kind of got to a point where we're actually getting some sounds out. So that's quite nice, isn't it? There's not so much of a click there anymore, because it's immediately going to full volume. But what we want to do eventually is to be able to kind of create an envelope over that, so the sound builds at a certain rate, it sustains at a certain volume level, and then it decays, or it releases down at a certain rate. So we could have it so it builds up slowly. So when you're playing a church organ, when you press the keys, there's a kind of a swelling of the note as air goes through the pipes, and then as you release, it's a relatively quick cut-off because there's no air going through, but there's that kind of build-up, what's called the attack. It's a long attack. The volume kind of exceeds the maximum volume, drops down to a sustained level, and then kind of decays away. It kind of releases quite quickly. So we want to put that kind of effect in there. And because we started off with a I-sample provider, we've got these floating point samples. We can now start to, rather than just feeding our, if I go over to the view model, rather than just feeding our, where is it? Our, gone. There's the on. Yeah, rather than just feeding our oscillator directly into the sample wave provider, we can feed the oscillator into a whole series of digital signal processing effects. And one of the things we're going to do is put it into a mixer. We're also going to put it into one of these envelope generators, so we can get a nice sound envelope and vary that envelope for different instruments. We're going to put it into a volume control. We're going to put it into some kind of visualization, maybe visualize the waveform that comes out, or maybe the spectrum analyzer. We can see the frequencies, which means we need to do use a component to do fast Fourier transforms on that, to change from time to frequency. So rather than time on the x-axis, we want to convert to frequency on the x-axis, and that's what the fast Fourier transforms will do for us. So Linksump says, what if you got your mic to read in the sound and spit it out as a synthesized sound? Well, you could do that, yeah. Yes, I'm not going to write my own fast Fourier transform though, Phil Snowball. We're going to use one that's in the N-Audio library to do it. It takes care of all the complex numbers, and what we're going to need to do is either write our own visualizer, or we might try and borrow a visualizer from another library. Fast Fourier transforms, they're easy. Yes, it's not something I'm going to tackle on stream. We can have a joint fast Fourier transform stream in the future if you want. If you've got one that you've already written, we can have a look at it. It's got to take in floating point samples and spit floating point and spit the right kind of stuff out. But I'm sure you can look at the the interfaces that if you actually, in fact, if you go to the N-Audio GitHub site, is over here. Where would it be? DSP FastFourierTransform.cs. So have a look at that and improve that implementation. As long as you adhere to the interface that provides and that it spits out, which is basically it's an iSample provider. If we go and look at it, all it is an iSample provider, I think. Is it? No, it's not. Okay. No. Okay. I'm not sure what it is then. It's a static class. Okay. So we're going to use another sample provider to apply this. It does things like these window functions as well. So it's got 3 window functions: the Hamming window, the Han window, and the Blackman-Harris window. I don't know if you did all that kind of stuff in yours, but that's basically to make it to improve the I only did this course the other day, and I still can't remember. It basically improves what you see on the visualizers when you have the graph of frequencies. Gives you a better view of that. I'm sorry, I'm being a bit vague. It's all very new to me, so yeah. So I'll have to revise that next time I come back. I'll tell you what the window functions are there for. But they were the Fast Fourier Transform class here does have those window functions, 3 different window functions you can choose from. Okay, well, that's pretty much what I wanted to get to. One thing I did want to just let you know is there's a new site which was launched today called Notify.me, which is a way to get notifications about your favourite streamers. I've signed up, as you can see. This is my page. If you want to try it out, then all you need to do is have a look at it. In the next couple of weeks, there are going to be mobile apps that come with it, and the functionality of the website itself will have added. A lot of it's disabled at the moment. It's very, very new, and it came out today, I think. So that's something else you can use to be notified. As usual, I'll just post in my GitHub. So if you want to look at the code we've written today, it's in a very crude form, but thank you, Upgrading Dave. Thanks. I'm glad you enjoyed the stream. So there's the GitHub. Fuel Snowball, if you want to look at that and submit PRs, then you please do, and I'll seriously consider it, and we'll look at it on stream if we intend to kind of use it. I'm very happy to consider any PRs to any of my work. This will be on YouTube tomorrow. This is my YouTube channel. Do go across there and subscribe. It's free. It helps me out if you subscribe. If you're not a follower of my Twitch channel, please hit the follow button. It'd be very, very kind of you to do so. You get notifications that way as well. On Twitter, follow me on Twitter, and you also keep kept up to date with when we do pop-up streams. There might be a pop-up stream tomorrow to continue this work a little bit further. It'll be a short stream, but we may do that. Otherwise, we're going to be rejoining not next Monday, but Tuesday, because on Monday I've got a family's birthday separate celebration. So the next scheduled stream will be 9 o'clock in the evening UK time, 8 o'clock in the evening UTC on Tuesday. So please make a note of that. If you do join on a Monday at 9 o'clock, I won't be there because we'll be out celebrating a birthday. Okay, so let's push this code to GitHub. So this is episode 34. As I say, it is in relatively crude format at the moment. It's going to be improved, never you fear. But it's my first attempt at this WPF malarkey. So as I say, it's going to be pretty crude in that respect. So that's that pushed up. Rockets. We better mention rockets. So let's have a look at our launches command. So we can do launches SpaceX. The next launch should... Come on, bot, are you alive? Interesting. Interesting. Looks like the bot is not alive. We'll start the bot, shall we? I must have closed the bot down at some point. There we are, the bot's alive again. So let's do launches SpaceX again. So in a few days' time, the 11th of June, we've got a Falcon 9, which is launching the RadarSat constellation of satellites. And then, hopefully, on June the 23rd, there'll be a Falcon Heavy launch, which will be absolutely amazing. So this is STP-2 for the Air Force. Once again, we're going to try and land all 3 boosters, with the 2 boosters coming back to Cape Canaveral and 1 landing out on a Jones ship. So that should be fantastic. Actually, there's another launch on July the 1st. It's another Falcon 9. So you can see the full kind of layout there. Launches ULA. I'm not sure what the ULA are doing. So there's an Atlas 5 launch on June 27th. So the Atlas 5 launch is always quite fun. And let's just do one more. One of my favourite small launch providers is Rocket Lab. Let's see if they're doing anything. So Rocket Lab have got an Electron rocket launch on June 25th. That's at an NET date and time, so it may not happen on June 25th. But if you've not seen an Electron launch, they're quite fun. They're only a small rocket, but it's quite a fun rocket. And you can see there's actually a launch of a Lunar Scout there later on in September, if that's ever going to happen. Oh, it's in 2020. That's interesting. So they haven't got an awful lot on their schedule on Rocket Lab. Okay, so that's our small section on rockets. Unless you've been under a stone or something, or you'll know that I'm a big fan of SpaceX and rocket launches and things like that. Okay, so let's go and find someone to raid, shall we? Thank you everyone for staying with me today. That's been a really enjoyable stream. Things kind of ended up in the right place. We got some tones coming out of the synthesizer. It's not a very good synthesizer at the moment. We want to be able to play chords. We want to be able to do a lot more kind of variation on what we can do at the moment. But we've made a good start. Let's go over to here, and I think what we're going to do is we're going to raid Chris Jones. Look at it. Or is he actually? He's hosting me. Okay, can't do that then. Let's have a look at CodeRush. Let's go and raid CodeRush. So if you haven't seen CodeRush before, do stay with me. He does amazing work. He's doing Dungeons and Dragons kind of campaign management with a wonderful kind of animated dice and explosions and blood spurts and all kinds of amusing things, all written in C# and in TypeScript. So if you're stable, does the project require preview? No, it doesn't. It requires .NET Core 3 Preview 5, but you don't need to have the Visual Studio 2019 preview. If you want to use the preview bits in standard 2019, just go up to Tools, Options, and then select Preview features here under Environment, and then just tick the box that says Use Previews of the .NET Core SDK, and you'll be able to use .NET Core 3 Preview 5 in your standard installation. Okay, so I didn't want to go to preview SDK and a preview preview Visual Studio, so I found that option, and it works fine. Okay then, so let's go and raid CodeRush. Thank you everyone for being with me on this early stream, and we'll see you either tomorrow for another early stream, which will be a pop-up stream, or the next scheduled stream will be on Tuesday, not Monday, so Tuesday 9 o'clock in the evening UK time. So thank you again, and let's join this raid.